Good morning, students. In this class, I'm going to discuss about digital transmission, which is one of the important part of the computer networks, and I have already discussed all of the different basics of computer networks. So, in this chapter, I am going to discuss about digital transmission. What are different types of digital transmission? How analog data is transmitted in digital signals, how digital data is transmitted in digital signals, how digital data is transferred in analog signals, etc. etc. So first, digital transmission means it is the transmission of signals which vary discretely with time between two values of some physical quantity, one value representing the binary number 0 and other representing 1. So if we see, data is transferred in the form of bits between two more digital devices. So there are two methods used to transmit data between digital devices: serial transmission and parallel transmission. These are also where I am going to discuss. Uh, so what are the advantages of digital transmission? So now if we see, data or information can be stored in two ways, so analog and digital. So for a computer to use data, it must be discrete signal form. Similar to data, signals can also be in analog and digital form. To transmit data digitally, it needs to be first converted digital form. So how we convert digital to digital conversions? So first, in this section explains how to convert digital data into digital signals. So it can be done in two ways: line coding and block coding. For all communications, line coding is necessary, whereas block coding is optional. So what is line coding? So if you see the process of line coding, the process of converting digital data into digital signal is said to be line coding. So digital data is found in binary format. Digital data is found in binary format, 0 and 1. It is represented, stored internally as series of ones and zeros. If you see line coding scheme, then sender and this is sender sending some digital data consisting stream of bits 0 and 1s. So encoder convert digital data to digital signals. So this is the signals: 1, 0, again this is 1, this is 0, this is 1, this is 0, in this way, and decoder will again convert the digital signals into digital data. So this is the receiver. In this way, the digital signals is denoted by discrete signal which represent digital data. There are three types of line coding schemes is available. Now what is unipolar, polar and bipolar? So line coding scheme can be three types: unipolar, polar and bipolar. So what is unipolar? So in unipolar encoding schemes, we use single voltage level to represent data. So in this case, to represent binary 1, high voltage is transmitted, and to represent 0, no voltage is transmitted. This is also called unipolar non-return to 0, because there is no rest condition. It either presents 1 or 0. If we see here, so this is implicit. So 0 represents no voltage, 1 represents positive voltage, 0 no voltage, positive voltage. In this way, we have the represent the binary signals. So the digital signals. Now polar encoding. Polar encoding schemes use multiple voltage levels to represent binary values. Polar encoding is available in 4 types. Polar, we use multiple voltage. So here again it is divided into 4 types. There is polar non-return to 0, polar NRZ. So it used 2 different voltage levels to represent binary values. So generally positive voltage represents 1, negative voltage or negative value represents 0. This is also non-return to 0 because there is no rest condition. So NRZ scheme has 2 variants, NRZ L and NRZ I. So what do you mean by NRZ L? So this is the NRZ L. 0 represents negative voltage, 1 represents positive voltage, 0 represents negative voltage. In this way we have this, we can represent this binary bits as this digital signal. So again if we see NRZI, so here is different. You see 0, this 1 comes, then it changes the states, again 0 is same, again 1 comes, it changes the states, again 0 is same, again 1 comes, this is way. So if you see non-return Z L change voltage at when different bits encountered, whereas non-return Z I changes voltage when 1 is encountered. So now return to 0. So RZ problem. The problem with non-return to 0 is that the receiver cannot conclude when bit ended and when the next bit is started. So in this case, when sender and receiver clock are not synchronized, then we have return to 0 uses 3 voltage level, positive voltage to represent 1, negative voltage to represent 0, and 0 voltage for none. Signal sense during which no between each bits. So in this way, if we see 0 for negative, none, and 1 for positive, again none, 0 for negative, again none. In this way we have see the coding. Now Manchester. So what is Manchester coding? This coding schemes is combination of return to 0 and non-return to 0 L. So but bit time is divided into 2 halves, so it's transmitted in middle of the bits of the bit and changes phase when a different bit is encountered. So different Manchester. This encoding schemes is a combination of return to 0 and non-return to 0 I. It also transmit at the middle of bits but change phase only when one encountered. So bipolar encoding, here we see bipolar encoding uses 3 voltage levels, positive, negative, and 0. So 0 voltage represents binary 0 and 1 bit represent by altering positive and negative voltage. So if we see the amplitude and signal 0 and 1, in 0, 1, 0, 1, 1, 0, 0, 0, 1, when 1 actually 1 get 1s, that it changes that. So this is the bipolar. Now block coding. So to ensure accuracy of the received data frame, redundant bits are used. For example, in event period, 1 bit is added to make the count of ones in the frame is even. In this way the original number of bits increases. This is called block coding. So block coding is represented by slash notations, MB and NB. M means M bit block, is substituted with n bit block, where n is greater than m. Block coding involves three-step division, substitutions, and combinations. So after block coding is done, it is line coded for transmission. Now come to analog to digital conversion. So microphone creates analog voice and camera creates analog videos, which are treated as analog data. To transmit this analog data over digital signals, we need analog to digital conversion. So how analog data is converted to digital signals or digital conversion? So analog data is continuous stream of data in the wave form, where digital data is discrete. To convert analog wave into digital data, we use pulse code modulation, PCM. So PCM is one of the most commonly used method to convert analog data into digital forms. It involves three steps: sampling, quantization, and encoding. So here we see the sampling, how occurs. So we take the analog signals, then we make samples. We divide the whole signal into subdivide into some parts, some small components. So the analog signal is sampled every t intervals. Most important factor in sampling is the rate at which analog signal is sampled. According to Nagel's theorem, the sampling rate must be at least 2 times of the highest frequency of the signal. So now next to quantizations. So sampling, this is we have done, then we make quantization in this way. Sampling as discrete from a quantization. Every discrete pattern shows the amplitude of analog signal at that instance. So quantization is done. So this is the amplitude it shows in every discrete. Between maximum amplitude value and minimum amplitude value. Quantization is done between the maximum amplitude value and minimum amplitude value. Quantization is approximation of instantaneous analog value. Now encoding, if we see encoding scheme, then after quantization we do encoding with this, and which convert the analog signal into discrete stream of bits. So in encoding, its approximation value is then converted to binary formats. Now we come to transmission mode. We have already discussed in previous other class also, but here again I give some basic concept. The transmission mode decides how data is transmitted between two computers. The binary data in the form of ones and zeros can be seen in two different modes: parallel and serial. So parallel transmission, if we see at a time lots of bits are transmitted through their different ways. So here we see 8 bits are transmitted at the same time with 8 ways. So receiver, so in this way the binary bits are organized into groups of fixed length. Both sender and receiver are connected in parallel with the equal number of data lines. Both computers distinguish between high order and low order data lines. The sender sends all bits at once in all lines because the data lines are equal to the number of bits in a group. So or data frames, a complete group of bits data frame is sent in one go in one time. Advantage of parallel transmission: high speed, and disadvantage is the cost of wires, so as it is equal to the number of bits sent parallel. So if we see another transmission mode, serial. So in serial transmission, bits are sent one after another in a queue manner. So serial transmission requires only one communication channel. So sender transmits stream of bits one by one to receiver. So serial transmission can be either synchronous or asynchronous. So how we differ this? Asynchronous serial transmission is named so because there is no importance of timing. Data bits have specific pattern and they help receiver recognize the start and end bits. For example, S0 is prefix on every data byte and one or more ones are added at the end. The two continuous data frames which may have gap between them. But in synchronous serial transmission, if we see, timing in synchronous transmission is important as there is no mechanism followed to recognize start and end bits. There is no pattern, prefix, suffix method. So data bits are sent in bursts without maintaining gap between bytes. Single burst of data bits may contain a number of bytes. Therefore, timing becomes very important. So now come to the analog transmission. So if we see digital transmission, then we come to analog transmission. The send of digital data over an analog media, it needs to be converted into analog signals. So there can be two cases data formatting. We have band pass and low pass. So band pass, the filters are used to filter the pass frequencies on your interest. A band pass is a low band frequencies which can pass the filter. In low pass is a filter that pass low frequency signal. So when digital data is converted into a band pass analog signal, it called digital to analog conversions. And when low pass analog signal is converted to band pass analog signal, it is called analog to analog conversions. So digital to analog conversions, when data from one computer is sent to another via some analog carrier, it is first converted into analog signals. So analog signals are modified or reflect digital data. So an analog signal is characterized by its amplitude, frequency, and phase. There are three kinds of digital to analog conversions. So first is amplitude shift keying. In this conversion technique, the amplitude of analog carrier signal is modified to reflect binary data. So this is the amplitude shift keying. We see this is time and this is represents 1, this is 0, this is 1, this is 0, this is 1. So if we see the one binary data represents 1 digits, the amplitude held, other it is set to 0. Both frequency and phase remain same as in the original carrier signal. Or if we see frequency shift keying, in this conversion technique, the frequency of analog carrier signal is modified to reflect binary data. You see, this is in this and this is 1, this is 0, this is 1, this is 0, this is 1. So it is the frequency is different from to represent binary 1 or 0. So this technique used to frequencies f1 and f2. One of them, for example, f1 is chosen to represent binary digit 1 and another is used to represent binary 0. Both amplitude and phase of the carrier wave are kept in same. Now phase shift keying, in this conversion scheme, the phase of the original carrier signal is altered to reflect the binary data. Is here you see this phase, this is, and this represent 1, and this is represent 0. So both are different. Again for 1 this, and again for 1 this, and 0 start from this and this way. So when a new binary symbol is encountered, the phase of the signal is altered. Amplitude and frequency of the original carrier signal is kept same. Now quadrilateral phase shift keying, quadrilateral phase shift keying alter the phase to reflect two binary digits at once. This is done in two different phases. The main stream of binary data is divided equally into two substreams. The serial data is converted to parallel in both substreams, and then its stream is converted to digital signal using non-return to zero technique. Later, both the digital signals are merged together. Now come to analog conversion. So analog signals are modified to represent analog data. This conversion is also known as analog modulations. So analog modulations is required when bandpass is used. So analog to analog conversion can be two types: analog modulations or analog to analog. Amplitude modulation, frequency modulation, and phase modulation. So in amplitude modulations, in this modulation, the amplitude of the carrier signal is modified to reflect the analog data. So here if we see, this is the analog signals, analog data, then carrier is applied. This is the carrier wave, carrier signals. Then finally we have the amplitude modulations. Amplitude modulation is implemented by means of multiplier. The amplitude of the modulated modulating signals is multiplied by the amplitude of the carrier frequency, which then reflect the analog data. The frequency and phase of the carrier remain unchanged. This is we see. Now if we see the frequency modulations in this method, by in this modulation technique, the frequency of the carrier signal is modified to reflect the change in the voltage level of the modulating analog signal or analog data. So here analog signal is this, carrier wave is this, and again we combine. If we apply frequency modulation, then this, you see, this is from this frequency is different and this frequency is different, so the amplitude and phase of the carrier are not changed. Now phase modulations. So in the modulation technique of phase, the phase of the carrier signal is modulated in order to reflect the change in voltage amplitude of analog data signals. So here you will see, this is the analog data, this is the carrier wave. Here phase is actually changed, so amplitude and frequencies remain same here. So in this way we have this type of transmission and conversion of data and signals in computer networks. With this I conclude my today's class. Thank you. We will meet in the next class with different topics. Thank you.